All right, good morning, everybody. Had to do a little bit longer than normal intro. I'm still trying to. Right now, I'm trying to, our password's changed, and I have to get onto my, or I have to connect to the school's Wi-Fi to change my password. So I'm going to drive to the parking lot of this elementary school that's just down the street to change my password. The issue is that my car is stuck underneath a tree right now, so I'm waiting on the guy to show up at like 9:30 in order to remove everything from underneath that tree. So hopefully they'll get here and then I can actually have access to my car. But until then, we're going to talk about biodiversity and human impacts on that biodiversity. So one of the things that we had originally talked about, this was pre-Christmas break. One of the things that we had gone over was actually what is biodiversity. And so I wanted to originally start with some definitions so that we're kind of on the same page as far as what I'm going to be talking about, or what different terms I'm going to be using. So the first big one that we're going to use is biodiversity. No, I wanted to. Hold on a second while I fix this. I don't know why it's. I want this. Crop. 200%. Back to this window. And I want the brush turned on. Okay. So the first one we're going to go over is biodiversity. And this is just a variety of organisms in an ecosystem. So if you have if you have an ecosystem that's dominated by one thing, so I guess take the what would be considered the perfect yard, right? The perfect like front yard. That would have a very low biodiversity because there's only one species of it. But then you look at something like a tropical rainforest, and they are very, very diverse because there's a large variety of organisms within that. Then you have renewable and non-renewable resources. So renewable resources are sometimes considered to be green resources, and these are resources that replace themselves as quickly as they're used up. Think about this as like balancing a budget. All right, if you make $100 a month and you spend less than $100 a month, that would be considered a renewable resource. Non-renewable resources are resources that are limited in supply because they're used up faster than they're replaced. So an example for this would be fossil fuels. So take your example, if you get paid $100, but you spend $110 every month, right? Eventually, you're going to start to dig into your savings and you're going to run out. So that is non-renewable resources. It's anything that the way that we kind of sum it up, or the easiest thing, is we can't replace it. And the reason that we say we can't replace it, or why fossil fuels is considered to be non-renewable, they do renew eventually, but they renew at such a slow pace that we could just say that they don't renew. Compared to renewable resources, like there are timber facilities that they grow massive farms worth of loblolly pine, which is a type of pine tree, and they grow it just like you would grow corn. And it grows, and once it gets into appropriate size, they cut all of them down, use it for wood resources, and then they replant all of them, and they repeat that exact same thing over and over. That is a renewable resource because we replace those as quickly as we use them, compared to clear cutting if we just go into a forest and we remove everything that we can and we don't replant. Conservation is, notice the big thing of this, the study of loss of Earth's biodiversity and the ways that this can be prevented. All right, it's not just the prevention itself. And kind of the first big person in the U.S. that we would think of as a conservationist would have been Teddy Roosevelt. He was really big into, he set up national parks and things like that to preserve the landscape. And he did a lot of that by looking at what we had lost, things like that. And Teddy Roosevelt was a hunter. He was, one of those guys that he went out there and he would hunt and live off the land and stuff like that. But his understanding with it is, if I kill 100 buffalo, then there eventually hits a point where they won't stop replacing themselves. Extinction, this is the process by which all members of a species die out. There is a list of species that are currently extinct. So they have what's called the IUCN Red List. And if you Google IUCN Red List, I know this is a new website to everybody. So this is Google. You can type in questions into here and you go to the IUCN Red List. And they have a lot of these species that are that they consider to be threatened, and they give them a categorization. So EN is danger, VU is vulnerable, CR is critically endangered, and then so here's kind of the categories. So data deficient, least concern, near threatened, vulnerable, endangered, critically endangered, extinct in the wild, and then extinct. So once a species is considered to be extinct, that means that the last individual has died out. So right now, there are quite a few species that are on the extinct in the wild list, and the next species, or if everything kind of stays the way it is, the next species that will go extinct is a rhino species. There were 3 individuals left, 2 females and 1 male, and the male died a few years back. So they only have 2 females left, and they are on their way toward extinction. Endangered is when it's identified to likely become extinct. And this is kind of the key behind it. It's not just that there's very few individuals, but out of those few individuals, it's likely to become extinct. There's a grass that grows in serpentine soils in California. Serpentine soils are soils with really high amounts of salt on them. That species is not likely to go extinct, but its habitat is limited. Biodiversity hotspots is biogeographical regions. So basically places on Earth that contain a high amount of diversity, but is also threatened with destruction. So the big one that we think about with this is the Amazon. So the Amazon is kind of this big one that everyone considers. The reason being is because it's threatened with the destruction of it. We have displaced quite a few by turning the Amazon into farmland. And then the last one is climate change. This is measurable long-term changes in Earth's climate. Notice the key here is long-term. Today it's, we're beginning to mid-May in Indiana. So yeah, I mean, we're getting into mid-May in Indiana, and it is 40 some odd degrees out. Does this give me? No, that doesn't give me the weather. That doesn't either. But it's 40-ish degrees outside today. That is not long term. That is just daily, and that's weather. So there's a big difference between weather and climate. So the fact that it snows out doesn't mean that climate change is not real. It just means it snowed out. Now, if that happens long term, let's say we had that one day in April where it snowed. Let's say that was 2 weeks, and then it happened again the next year, and it happened again the next year. Then that turns out to be long term, and that's kind of where our concern is. So, human impacts on biodiversity. So obviously, the name of this lesson, human impacts, we're going to look at how a lot of this is done artificially by us. And human impact is a major threat to the planet's biodiversity. And it's because the human population has grown exponential. Go to my blank Word document. If you look at, so this is time, and this is population. If you look at a lot of it, and we'll put this as 1950, because that was kind of the tipping point. But if you look at this, all throughout human history, we kind of remained at this really low level, right? And there were a couple peaks and valleys, and then all of a sudden it just skyrockets. So now we sit at around 7 billion. So it's a little over 7 billion. I think it's like 7.3 billion people. But this is what I mean by exponential. So the growth rate has stayed the same regardless of the population. This makes the population grow faster and faster as it gets larger. Because if you have, I mean, think about the whole thing. If you have 1 penny, all right, you have 1 cent, and that doubles every single day. So times 2, then you have 2 cents. And then if you multiply it by 2, then you've went up to 4 cents. All right. Notice here you've only added 1, but here you've added 2. And if we double this again, you end up with 8. And that's plus 4. And if you do this at the end of a month, you'll end up a millionaire. And that is what's meant by exponential growth. It means rather than just adding a fixed amount of like plus 10, you add an exponential number like times 1.8 or times 2. So that's exponential growth. Eventually we'll reach what is called carrying capacity, which we've talked about carrying capacity before. So carrying capacity is the number of individuals that can be supported. So the number of individuals supported. So why is this important? Well, the Earth does have a carrying capacity. All right, it's estimated to be between 12 and 20 billion people. We're at about 7. We're a little over 7. So why is this? Why is this considered to be a big deal? Once you go over carrying capacity, all right. So if this is carrying capacity, once you go over it, these individuals in this area will lose some resource that's required, and it'll cause it to dip down below. So this is the dangerous area. Once you are above carrying capacity, then there's a resource. Okay, sweet. The tree guy's here to remove the tree off my car. Once you go above this point, you're missing out on a resource. So what resource is it for us? Anyone who's taken a plane flight across the US has seen that there's a lot of empty area. So looking at picture. Looking at a map of the US, going to satellite view, you can see there's a lot of space in here, and you could see big cities kind of show up as this grayish area. Like when I lived in South Dakota, you could see that here's a city and a lot of this is just open area, right? Why? Why is it that we have this limit if we have so much open area? I mean, look here in Nebraska, Norfolk, and then all of this empty space that's kind of in here. I mean, yeah, there's like farms and stuff like that. You can always tell farms because of it's really dry out here, and they have these kind of circular things that spin around their fields and leave these rings. But why is it that we have this empty space and we're worried about carrying capacity? Well, the big limitation is food. We have to be able to feed everybody, and it's the estimation that we currently have is based off of this is what will happen if we lose enough food. So we're working together with new technologies and things like that can adjust this carrying capacity. So whether it's on the low end of 12 or the high end of 20 is based off of kind of what technologies are used. But you have to think that as we turn more space into farmland, that is threatening those species that were originally there. And the big one is the Amazon rainforest. And this is not the Amazon rainforest. This is Madagascar. So in this area, these trees were removed from this area. And why were they removed? Well, the number one thing is to turn this area into farmland. And there's other reasons too. It's not just I don't want to seem like I'm like going against farmers. It's exactly the opposite. Like I'm a huge proponent of agriculture. I think that agriculture is very interesting, and it's one of those big interests of mine in science. And the thing with science is that we're improving it with agriculture, we're improving it every single day through better technologies. So why is this a big deal? Well, because in a lot of these areas, they don't have the money for a lot of this technology. And what they do instead is they go through and they clear this land in order to plant crops into. They're not concerned with what was here before or anything like that. So it's how it's done, not necessarily that it's done. So one of the things, so what are some of the human mediated causes of biodiversity? Well, land change use. Humans destroy natural landscape as they mine for resources in urbanized areas. The place where my house sits at used to be a forest. So I'm as guilty as anybody else for this. And is detrimental as it displaces a lot of these residing species and reduces their available habitats and food sources. There's also pollution. I have a front yard just like everybody else, and it has to follow city regulations, so you can't have weeds over a certain height and all this stuff. And for us, having this is like the world's loudest truck out front removing this tree. When you remove a lot of this stuff, now these trees are not providing a service to the environment. It's called an ecological service. They're not providing that service. So you end up with higher runoff and things like that. That is a problem that I have at my house because I live by a river, because I live by Foster Park. And because of that, I have a lot of flooding every single time it rains. And it's not because I live next to a river. It's because there are no species around that area to kind of absorb a lot of this water that ends up in the environment, right? If you have an individual tree takes a lot of water to support and grow and sustain. And so when you remove that that tree, that water has to find a place to go, since it can't go up into the tree. And this is a big thing. Like, you know, the Riverfront Development Project took this into account. Can we put species along the edge of the river that will promote or that will reduce flooding and promote people to live next to the river? Sorry, I'm watching them. They just cut down my the what was left of this tree. So I had this eastern redbud that was growing out front, and it actually flowered this year, and the windstorm that went through yesterday pushed it over on top of my car. So they're having to remove this tree so that I can get my car out from underneath of it so I can do the things that I need to do today. Because like I have to reset that's why grades haven't been updated, because I've been locked out because I have to go onto Wi-Fi to do it. The other thing is introduced species, which we'll get to later. This is my area of expertise within ecology, is invasive species. So it's intentional or unintentional introduction of non-native species. They could negatively impact the ecosystem. They can also outcompete native organisms and displace them. So an example is when I was getting my undergrad, I did research on garlic mustard, which is a plant, stands a little under a meter tall, and moths that lay their eggs into it, or their larvae into it, or well, eggs that turn into larvae, they can't feed upon that plant. There's also resource exploitation, which we talk about this in environmental science with Tragedy of the Commons. It's where you go in and you just remove all of this stuff with no care about what it's going to look like afterwards. You cut down all of these trees because it makes you money, and you don't care about anything else besides that. You just need to fulfill a need of getting as much lumber as possible. So if you use a lot of this stuff, you can't actually turn a renewable resource into a non-renewable resource. Trees are a renewable resource until you remove enough of them to where the population can't sustain itself, and then it becomes a non-renewable resource. Renewable resources, yes, solar is considered to be a renewable resource, even though technically over billions of years it is a non-renewable resource, because the sun right now is working its way toward destroying itself. This will not happen in our lifetime, but it is something that will happen eventually. Wind is a renewable resource. We're taking, the movement of the planet and the movement of the moon and all of this stuff that generates wind, and we're capturing that energy and putting it into lights and things like that. So then we're going to go on to climate change. And right now, the current climate change that we're looking at is they're really loud outside. I apologize for that. It's due to increasing global temperatures, and this has been through human activity. So I have a picture. A lot of it is through burning of fossil fuels, and it's just not that we burn fossil fuels. Like, people have been cutting down trees and burning those trees in the form of wood or burning the wood in order to get heat for the longest time. And why isn't that considered to be a big deal? Well, a lot of it is because we're extracting this carbon that's been locked up into the ground for the longest time. We're extracting that and releasing that carbon, because remember, nothing can be created or destroyed. It can only change. So we're changing oil into carbon dioxide. And carbon dioxide is a greenhouse gas. Greenhouse gas meaning that it increases the temperature. If you've ever been inside of a greenhouse, in the wintertime, greenhouses actually have a pretty decent temperature. I have an atrium, which is half a greenhouse that's attached to my house. And in the wintertime, if the sun is out, I can open the doors to my atrium and heat will come out of it. It'll actually be warmer in the atrium than it is the rest of the house, and I can use that. And so that's what a greenhouse effect is. If you want a really good look at what greenhouse effects can do to a planet, look at Venus. Venus is comprised mostly of carbon dioxide and methane. And obviously there's other factors that go into it. Yes, it's closer to the sun, but it's so hot on the surface that it can melt lead. So how does this actually pertain to Earth? Well, a lot of it is our human activity. We need energy, right? We need energy like this, the microphone that I'm using, and the internet or the computer that I'm doing this on, and the camera and the light that are helping record, and the internet, my Wi-Fi router, and the computer and the device that you're using, or your phone or your internet. All of that runs off of energy. And so we have to be able to capture energy in order to use it. And the biggest way we do that is through through fossil fuels. In Indiana, a big source of energy here in Indiana is coal. One of our biggest uses is coal. We are switching over to green energy. But again, that's going to be really slow because it is one of those things that we're concerned about jobs. And while coal isn't as big as it used to be, there are kind of alternatives to that a lot of political agencies are kind of bringing up. Like, why can't we take someone who used to work in a mine? Why can't we teach them how to build solar panels or something like that? But that is a topic for another class. If you're interested, I teach AP Environmental Science, and that's one of the things that we bring up. So burning fossil fuels and also the growth of animal agriculture has caused large amounts of greenhouse gases in the atmosphere. Higher concentration of greenhouse gases trap more heat, resulting in warmer temperatures. And then that is what drives climate change. So here's a graph of atmospheric CO2 concentrations. So these numbers are climbing. The breaking point was supposed to be 400 parts per million. We broke 400 parts per million in 2012 or 2013. So that was a big tipping point, was breaking 400 parts per million. What that means is if you sample 1 million pieces of the atmosphere, 400 of it will be CO2. I know it doesn't sound like a lot, but it is a big impact. So when climate change affects the environment, as it's not able to sustain organisms, they have to adapt, relocate, or a lot of times they face extinction. And so climate change will have a huge effect on biodiversity. Looking at us, we cannot breathe CO2. I know there was a congressman that says CO2 is a natural gas and we can breathe it. We cannot breathe CO2. It is toxic to us. So as the atmosphere starts to increase in CO2, it is going to start to target people that are vulnerable with respiratory illnesses. So then we kind of go into conservation. So conservation is where we're kind of working to protect. I have a big hole in my yard now. So we're working to protect species and places where they live. And that's in order to prevent extinction. All right. We don't want extinction to happen. So what we do is we can't protect everything. So what we do is we look at things that are the most vulnerable. So an example is are those rhinos that I was talking about. All right. So there were 3 rhinos left. So it was 2 that were female and then 1 male. All right. Before that, everyone's like, well, why didn't they get the male to reproduce? Well, he was really old. So one of the things that they did was they tried to get him to mate. So we go through the list. Like, number 1, what can we do? Well, we can try mating. Number 2 was collect gametes and try to do it artificially. And then number 3, we can collect tissue. This is in the future if we get the ability to bring an organism back. 4, we can try hybrids. See if it's reproductively compatible with other species. But notice what this is. This is a Band-Aid. This is a Band-Aid that we've been trying to put on a wound of the fact that we have 3 individuals. So think of what this means when it comes to biodiversity. Actually, think of what this means when it comes to genetic diversity of these 3 rhinos. All right. What is that genetic diversity going to look like? Well, it's going to be really poor. All right. Because we have eliminated a lot of individuals from the population. All right. So when we talk about evolution and how you want to have a high amount of biodiversity, what's happened here is if you try to plot this on a bell curve, it won't plot because you only have 3 individuals. So it makes it very difficult to plot this on a bell curve. And so then we kind of get into like, okay, how did we end up in this situation? Well, rhinos exist in a lot of parts of Africa where providing hunting for people that are big game hunting, providing guides to them. This is how a lot of these places make money. Like, they're not making money off of like the person shows up there, they have to buy food, they have to buy so they have to buy food, they have to buy you know, all sorts of other stuff, lodging, water, transportation. They have to pay for the guides and all of this stuff. So that right there leads to income for this area, but it also led to only having 3 of these rhinos left. And now there are only 2 of these rhinos left, and they're both female. And I know that a lot of you haven't taken health class yet, but when you only have 2 and they are female, that is not great for the outcome of your species. And so then they look at, what can we do in order to kind of prevent this? So the creation of local, national, and international legislation, captive breeding programs. This is why when it says extinct in the wild, the reason it's extinct in the wild is because we're trying to get them to breed in captivity. Some species won't. They won't reproduce at all in captivity. Habitat protection, preservation, restoration is essential. There's a lot of different things that we can do, but this is where the issue kind of comes down to, is this was not natural. We did this by hunting it, and I mean humans. But we hunted these 3 rhinos down to 2 rhinos. And so then we have to look at, okay, what can we do in order to prevent this? Now, this is just rhinos. These were actually done by hunting. The other thing is habitat destruction has resulted in a lot of birds losing their population. So what legislation can be put into place? Well, you could do selective cutting programs. Rather than going in and harvesting everything, you go in and just harvest the ones that are the biggest, the strongest, the best, and ones that are near the end of their lifetime. That tree that was out front, it collapsed today, which means that they can take it and turn it into mulch or whatever. It has flowers on it, so it was still viable. It just couldn't survive a windstorm. So that tree can be turned into something else because it's no longer useful laying on the ground. One of the trees that I have out in front of my house is an London plane tree. It is not near the end of its life. I live in a neighborhood called Oakdale, so it's filled with oak trees, as the name suggests. Oak trees are big money trees, so as those trees start to approach the end of their life, why not go in and selectively harvest some of them as they're getting near to the end of their lifetime? And that way we could turn those into wood products rather than going in and just cutting every tree on the block down. With the rhinos and hunting, the reason that hunting is such a big deal is because in China, the horn of a rhinoceros is considered to have properties that when it's ingested, it works as an aphrodisiac. And we know that this is not true. So putting laws into place to say, this is not something that should be allowed will help out. There was an ivory ban that was put into place in North America, and that right there helped out a lot with indiscriminate killing of whales. Now there are villages of native Eskimos in Alaska that go out and hunt whales. They kill a whale, they drag it up using their boats, they drag it up to shore. They use the fats from the whale or the oils from the whale as fuel for lamps and lanterns and heat sources. They use the blubber as food. They use the bones to make weapons or other things to hunt with, or to build things around their settlements. So that is different than if it's just like, you know what, I'm just going to go out and off a lion because I have $40,000 burning a hole in my pocket. I'm going to go take care of a lion, just wipe it out. If you have $40,000 burning a hole in your pocket, just buy a Patek Philippe. That'll take care of it for you. So then I'm going to go through common misconceptions. So common misconceptions that there are. So a lot of this has to do with extinction rate. So I hate the typing feature in Paint. It's so bad. So move this up here. So the first misconception is the extinction rate is currently 1,000 to 10,000 times higher than the natural extinction rate. Now there is a natural extinction rate, all right? To emphasize that, there is a natural extinction rate. Why does it always have to go pixelated? So the natural extinction rate is how often species go extinct if humans were not there. So 1 to 5 species every year go extinct. So some people have thought that extinction is not a relevant issue. It's actually it's really relevant. So natural historic rate is 1 to 5. Human impacts have caused this rate to jump significantly, and it's kind of offset this balance of biodiversity. Next one is the greenhouse effect is not all negative. This was brought up by, I don't remember who it was. There was a speech one time. It's like, if we have global warming, that means we can grow crops further north. And that is not true, I guess, because you're going to lose a lot of biodiversity and things like that. But it's not just that, warming the earth. Okay, that's not the biggest issue. It's that when too much heat is trapped, it's like turning on the thermostat in your house. Having it set to 70 degrees is cool. Having it set to 75 degrees, that's a little warm for what you need it. Having it set to 80, that's overkill. Having it set to 90 is a massive waste. Just like when you have the air conditioning. Having it set to 60 degrees, that's a little too cold. Having it set to, 50 degrees, that's a huge waste. So that's kind of the second misconception. And the last one, an individual person can have an effect on biodiversity. So biodiversity is pretty large scale. Reducing the threats can, though, begin with a single individual. Smaller efforts like recycling and things like that, producing sustainable foods, which there's a huge misconception that sustainable foods are more expensive, like to shop and to buy something healthy is more expensive. That is a massive misconception. It's actually around the same price. It's not a big significant change. And if each person kind of did this, then it'd add up. And I'm going to admit it, like I'm one of the first people to it's kind of hypocritical, but I'm one of the first people to kind of break this. I enjoy playing video games. I enjoy, I'm into amateur radio, and my radio takes a lot of power. There's so many things that going on a bike ride, in order to get to where I need to ride, I have to transport my bike there, usually by driving it. And so there's things that I do that are not exactly environmentally friendly, but I try to do as much as I can. Like I recycle quite a bit. I tend to shop for sustainable foods. I do purchase GMOs because GMOs are actually more environmentally friendly than organic. When I purchase foods, I tend to look at more, even though yes, I could go vegetarian, and hamburger's my favorite food, I tend to shop a little bit more ethically because there are some food production facilities that are not environmentally friendly and others that are. So I tend to make better decisions when it comes to purchasing food. And a lot of that is based off of, or data that's been collected and information that's been collected over what you can and can't do in order to better serve the environment. I know this seems like it's been kind of like a really long rant, but it's opinionated, but a lot of the stuff, or all of the stuff that I go over, is based off of fact. All right, it all has to be based off of data and evidence. Again, this is a science class. In a science class, you can have an opinion, but that opinion has to be supported by evidence. I had a guy once tell me that in science, you're not entitled to your own opinion. You're only entitled to what you can defend. And so that's what we're doing here, is we are providing supporting evidence for a lot of this stuff. Is there supporting evidence for pollution and things like that? Well, yeah, I mean, polluting does save businesses money and things like that. But that's where you have to kind of start to formulate your own argument and your own opinion and your own views on this and use this information. I'm just here to kind of provide the resources for all of this stuff. All right. I know it kind of seems like it was a long rant. I'm going to put these definitions back up on screen so that if you wanted to, we'll erase all of my highlights from it. But this way, if you want to screenshot this or whatever, I hate that in this you can't do 150%. That would be perfect. I'm sure there's a way to do it. I'll figure it out eventually. I'll play with this off screen. But here's kind of a thing of all the definitions we went over. So if you want to come back later and screen grab this or whatever, then you'll have it. But that's pretty much all I have. I'm going to be moving over to Google Meets after this. Remember to be checking PowerSchool. Check PowerSchool every day. We are posting important announcements. We're starting to get near the end. Locker clean out is happening. It's going to be happening. Textbook turn-in is going to be happening. All of this stuff is occurring. So if you are if you need to turn all that stuff in, or you need to go in and clean out your locker, make sure that you're paying attention to PowerSchool so that you know when that's happening. Course selection sheets. Get your course selection sheets turned in. You can do it online. There's a link under PowerSchool. There should be one for guidance. Go to there and chat with your guidance counselor about that and get your course selection sheets turned in. If you have any questions at all, send me an email. All right, don't be afraid to send me an email and ask. That's what I'm here for. I'll get everything, I try to answer emails as fast as I can. Unfortunately, right now I'm having computer problems because you have to be in the building to reset your password. So after office hours today, I'm going to head over to a parking lot where I'm close enough to the building to get Wi-Fi, and I'm going to change my password, and then I should be able to do everything after that. I have to assess my car since it's been removed, or the tree has been taken off top of it. I have to go and assess my car and see if that's okay to drive. But there's also a school that's within walking distance of me, so I just need to walk down there and get that taken care of. Again, if you have any questions, send me an email. But that's all I have for today. Enjoy your Monday. Hopefully everyone had a great weekend. And I will see everyone either in Google Meets, or I'll see you on Wednesday for the next lecture. Thank you.